Good morning. In this lecture video, I'm going to explain one more example programs. So we'll consider one question which is appeared in the exam for 7 mark. Read the question. Write an ALP means assembly language program in 8051 to perform the following operation. So the operation is z is equal to x1 plus y1 into x2 plus y2, where x1, x2, y1, y2 are 8-bit hexadecimal numbers stored in the RAM location. That means program is to perform the operation z is equal to x1 plus y1 into x2 plus y2, and these x1, y1, x2, y2 are 8-bit hexadecimal numbers. They are stored in the RAM location. Write a subroutine for the addition. So here in this operation has two addition. One is to perform addition of x1 y1 and addition of x2 y2. Write subroutine for that. That means instead of writing the same operation twice in the main program, write a subroutine. Call that subroutine twice in a program. Write subroutine for addition, and one more condition. Assume that each addition result with an 8-bit number. So addition of this x1 y1 gives only 8-bit result. It won't exceed 8-bit. I mean carry flag will not occur. Carry flag will not occur. No need to consider carry flag. Assume that each addition result with an 8-bit number. So this is what the question. We understood the question right now. So and they are telling that the numbers are stored in the RAM locations, but they have not specified the address. They have not specified the address. So you assume an address. So you need to understand the memory concept. It's most important to write the program. Let's say this is the internal memory, and this is the content. Then this is the address. Let's say the address 30, 31, 32, 33 contains 30 contains x1, 31 contains x2, 32 y1, 33 y2, and we'll store the result of this operation. Even they have not specified to store the result, so we'll store the result at the end of an array, that is at the 34 low byte of result and at 35 I byte of a result. So this is what the memory view. Understood now? So we need to implement this operation. So we'll see the program. This is what the operation is supposed to be implement, and this is the internal. And here we'll use pointer register to point start address of x number. We say this is x number, x1, x2 are x number, and y1, y2 are y numbers. We'll use another pointer register, that is r1, to point y number. So r0 points x number, r1 point y number. So this is what initialization we supposed to do. So we'll see the program. Start with 00h. Okay, we need to initialize r0 to point x number now. So that is the address 13. So move r0 comma hash 30h. That means r0 to point x number. Similarly, move r1 comma hash 32h. So this is the start address of y. So r1 to point y number. Okay, na? And then call addition subroutine. Call addition subroutine. So I have named subroutine as addition. So it will go to addition subroutine. It will come here. I'm writing here. So here what we supposed to do? We need to add the number x1, y1. So r0 is pointing to x1 and r1 is pointing to y1. First get the number which is pointed by r0, that is x1 to accumulator. So move a comma at r0. So a is having x number, that is first time x1, second time x2, like that. So get the number x into a. Add with the y number that is pointed by r1. So use the instruction add a comma at r1. So what it performs? Add the number pointed by r1, that is y number, with the content of a, that is x number, and result will be stored in a. Result will be stored in a. So say return. So when it return to main program, a having the result, result of x1 plus y1. So that you store in B register, because uh, here you can use any other register, but I am preferring B register. Why? Because it has to be multiplied with the second result. So multiplication means operand supposed to be in either B register and IA register. That is why move B comma A. That means result of X1 and Y1 is stored in B register. So first operation is completed. To do the second operation, what we supposed to do? We should make R0 to point 31 and R1 to point 33. How do you do this? Increment. Increment R0, increment R1. So after this instruction executed, pointers are pointing to 31 and 33. Then call addition. Then call addition subroutine. Again it comes here. Now R0 is pointing to X2. That is copied to A. And then next instruction R A comma at R1. R1 is pointing to Y2. So it performs X2 plus Y2. X2 plus Y2. And the result will be in A. Then it returns to the main program. It returns to the main program. So when it returns to the main program, we can say immediately mul AB, because now recently A having the result of X2 plus Y2, correct? And B having the result of X1 plus Y1. So we need to perform multiplication of these two. No? So you say mul AB. So it performs content of A multiplied with the B. That means A having B having x1 y1 x1 plus y1 into A having x2 plus y2. It performs the multiplication. So as you know, after the multiplication, A having the low bit of result and B having high bit of result. So as per the requirement, we have to store the low bit of result at 34. So increment R1 to point at 34. So increment R1. So now it is pointing to 30. To this location, store low byte of result. That low byte of result is present in A. So say move at R1 comma A. A is the source value. So A is copied to the location pointed by R1. That means the low byte result will be stored here. Then again increment R1. Increment R1 so that it pointing to the location 35. 35. Okay. To this location we should use, we will copy the I byte result. I byte result is at B. Okay. So say move A at R1 comma B. So I byte result will be stored in the into the location pointed by R1. Clear? Huh? Over the operation, say SGEM here, control loop, control loop. Okay. And N you should not put N here. Okay. Because if you put N here, these instructions are ignored. These instructions are ignored. So we need to put N here. Okay. End of the program. So this is the program which implements the operation z is equal to x1 plus y1 into x2 plus y2. Okay. So using subroutine. So like this, any expression can be given. Suppose if they give, if they extend this, right now, x1 plus y1 into x2 plus y2 into x3 plus y3, they can extend. Or old result can be old x1 plus y1 into x2 plus y2 divided by x3 y3. Correct. So for x3 plus y3. So for that addition, we use the right. I mean, 3 times we supposed to use addition. So whenever it is required, we call subroutine. So this is the program example using a subroutine. So we continue in next video. Thank you.